Wow, this has been a great day. Okay, it's 11:15 at nighttime and still working, but that's okay. We're doing 1.11 notes. We're getting close to the end. Oh my gosh. By the way, my name is Mr. Krause. My partner in crime, her name is Ms. Newman. And together we own, or we run, www.NK, that's Newman Krause Infinity. It's like how long math class ends. I've told that joke like 6 times. You guys getting tired of hearing about it? Well, if you've only watched this one video, which probably I'm going to get a lot of videos on this one, little watches on this one, you may not have heard that funny joke before. Oh my gosh, I'm tired. Dunkin' Donuts coffee. Oh. All right, we're going to do today, we're going to talk about a system of 3 equations. So let's count them. 1, 2. Wow, I'm a hell of a math teacher. Oop, heck of a math teacher. I got 2. Oh, 2 systems. Oh, so we're just going to warm up. We're just going to warm our hands up on how to do these problems. We're going to use the elimination method to solve these ones. Okay. So we got 9x minus 2y equals 7. And then I've got negative 3x plus y equals negative 3. All right, so let me grab a different color pen. And what I want to do with the elimination method is, is get a pair of additive inverse, a pair of opposites. In this case, if I multiply this equation by 3, right here I end up with negative 9, and that's kind of what I want. So we're going to recopy the first equation, 9x minus 2y equals 7, and then negative 9x plus 3y equals negative 9. Ka-ching. These cancel. I end up with y equals negative 2. Just checking my answer. That looks about right. Okay, so far so good. But I'm not done. I still got to find y, or I still got to find x. So I'm going to say, okay, 9 times x minus 2 times negative 2 equals 7. Okay. So this is 9x plus 4 equals 7. Or 9x equals 3. What? Or x equals 3 divided by 9, which is really just 1/3. Huh? Really? That doesn't seem right. Maybe I should check that. Let's check that. Let's do that. Let's check that. Let's bring that over here. I'm going to check it in. Let's do the check in black. So I'm going to check it in the second equation, which is right here. So I'm going to do negative 3 times x, which is 1/3. Oh, that'll work out nicely. Plus a negative 2. Does that equal negative 3? I don't know. Let's see. Negative 3 times 1/3, that's negative 1. And then this is just minus 2. Oh, yeah, that does equal negative 3. Negative 3 equals negative 3. So it looks like that's my answer right there. 1/3 negative 2. Ka-ching. All right, let's take a look at this one. So I'm going to wrap parentheses. I'll go to blue. I'm going to wrap parentheses around this one. And I think it's probably obvious that I can multiply that first equation by 3, get 15 here, and that would be a nice additive inverse. So 15m plus 12m minus 12. Now, or equals negative 12. Remember, you're distributing here, and here. Don't forget that there, dude. So negative 15m minus 2n equals negative 3. And we'll lop these off. I get 10n. Somebody made a mistake. Oh, I don't have my work here. Oh, maybe it's right. Okay, so 10n equals, what is this? Oh, that's okay. That's not bad. That's negative 15. Divide by 10. Divide by 10. I get n equals negative 3 over 2. It's not gorgeous, but who knows? Maybe it's right. Maybe it's right. So now we're going to plug that in. So I'm going to do 5m plus 4 times negative 3 over 2 equals negative 4. So 5m minus 6 equals negative 4, because that's minus 6. Add 6, I get 5m equals 2, or m equals 2 over 5. I know we all hate fractions, but I think those might actually be the right answer. So let's just do our check. I'll do a check in black. All right, let me see if my big head's out of the way. Get up as high as I can. I'm going to check it in that second equation. So check is my check. So it's going to be negative 15 times m, which is 2/5, minus 2 times n, which is negative 3 over 2. Does that equal negative 3? Well, this is negative 30 over 5, which is really just negative 6. And a negative times a negative is positive, and the 2's cancel. So I end up with positive 3. Does that equal negative 3? And I end up with negative 3 equals negative 3. Oh my gosh, it works! So in this case, my answers are m equals 2/5 and n equals negative 3 over 2. And I can't really write that as a point because it's m and n. M and n, isn't he a singer? Well, he used to be. All right, I'll be back. All right. Oh, look. It's a really long word problem. Oh, that looks like fun. Okay, let's see what we got. Matt decided to purchase his 18-karat gold necklace from a gemologist. Woo, it's late. When it's late, and I need my coffee. Luckily enough to have his jewelry store on the corner of Broadway and 7th Avenue. I think that's Times Square. The gemologist knows that 18-karat gold has 75% gold and 25% of another metal. He had access to, he had access to a large supply of gold that was 95% pure and a large supply of gold that was 45% pure. If the necklace is going to weigh 150 grams, how much of each type of gold must he mix in order to get an 18-karat gold necklace? Whew! All right, let's start with assigning some variables. Let me go to blue because we're going to need some lucky color on this one. So let x equal number of grams of 95% pure. And let's let y equal the number of grams of 45% pure. Because those are the kinds of gold he has to work with. And I know when I add up x and I add y, I have to end up with 150 grams. Okay, that one's not bad. Now comes the hard part. I'm going to make this necklace that is 150 grams. Correct? I want to know how much gold is in that necklace. So I need to know how much gold. It's not all gold. It's something else. It could be any other precious metal, but it's not all gold. I need to figure out how much gold is going to be in the necklace. And we were told right here that 18-karat gold has 75% gold. So if I have a necklace that's 150 grams, 75% is actually gold. So if I take 150 and I multiply it by 0.75, 150 times 0.75, I get 112.5. So there's going to be 112.5 grams of gold. Now, why is that important? Well, we're going to put some amount of grams of the 95%. So what we're going to do is say, okay, 95% of X is pure gold. And then if we add to that 45% of whatever y grams are, so 45% of y, that gives us how much gold we have there. 95% of x, that gives us how many gold we have there. When I add up that gold, it's got to add up to 112.5. That's the second equation. That was a tricky equation. I get it if you had troubles with it. We're going to multiply this first one by negative 0.95. So to get our opposites, or to get our additive inverses. So I've got negative 0.95x plus, excuse me, minus negative minus 95y equals, and now I got to do 150 times 0.95, 142.50. Now it's actually negative. And then the bottom is just 0.95x plus 0.45y equals 112.50. These I'm going to add up. These cancel, and I end up with negative 0.50y equals 30. Divide by negative, equals negative 30. Divide by negative 0.5, and I get y equals 60. Okay, let's see. That's half the battle. That means we're going to have 60 grams of that. Okay, so if y is 60, I'm going to just go back up this original equation. If y is 60, so I do x plus 60 equals 150. That means x has to equal 90. Oh, so x is 90. Let's see if that makes sense. I'm going to do this over here. So if I take 90 grams of 95% pure, so 90 times 0.95, let's see what I get. 90 times 0.95, 85.5. So that's 85.5 grams of gold, because 95% of it is gold. A lot of gold, but it's only 85.5 grams. The other 4.5 grams is something else. So then we're going to take 60 and we're going to multiply it by 0.45. Now, 45% of that 60 is gold, so I'll do 60 times 0.45, and I get 27. So that's got 27 grams of gold. And if I add that up, lo and behold, I get 112.50 grams of gold. And yes, that's the right answer. All right, kids, that's it. That's it for that one. All right, now comes the fun. 3 equations, 3 unknowns. Oh my gosh, we're going to have some fun with that. I'll be back. Okay. So here's how this is going to work. Step 1 for me. Step 1. Because the only way to do this is sort of a combination between the substitution method and the elimination method. So step 1 for me, is to isolate one of the variables in one equation. Not sure if I like the way I said that. I want to get one of the letters by itself in only one of the equations. So I'll take this first one. Let's take this first one. So we got 3x minus 2y plus z equals 2. I can get z all by itself. So I'm going to isolate z. I'm going to get z all by itself. So I get z equals. Now in order to get z by itself, that's got to go to the other side, and that's got to go to the other side. So when they move to the other side, their signs get changed. So that becomes 2 minus 3x plus 2y. I don't know why I put a 4. Plus 2y. Now, it's really important that you don't mess up a single step, because if you mess up a single step at the end, you're going to have like 0.48, 3, 4, 5, 1, 4, not going to work. Okay, so this is Z. Step 2. Substitute into the other two equations. Okay, so this is what Z is. So I'm going to do the first equation. The first equation is, or the second equation is, we've already solved for this one. I've already used this equation. So now I'm going to take what I learned and put it into these two equations. So 5x minus y minus, and again, anytime I substitute in using parentheses, what I found out Z to be, because right, the next thing is Z right here. So 2 minus 3x plus 2y equals 16. And the other one is x minus 3y plus 2 times 2 minus 3x plus 2y equals negative 9. Make sure I got that. 2 minus 3x plus 2y. So x minus 3y plus 2 times z. 5x minus y minus z equals 16. Now we're going to clean these up. We're going to clean these up. I can't find the right pen. Oh, there it is. So 5x minus y minus 2 plus 3x minus 2y equals 16. I just distributed that negative. So I got, let's see, I've got 8 x's and minus 3y. And I'm going to bring this 2 over here. I'm going to add it to the other side, so I get 18. There's an equation. And let's see. I got to distribute, so I get x minus 3y plus 4 minus 6x plus 4y equals negative 9. Okay, so now what we got to do is clean this up a little bit. So we get, let's see, that's negative 5x plus y equals. Now we're going to bring this negative 4 over. I get negative 13. So now I have two equations. So now, step 3. Use elimination method to solve for one of the variables. Sorry if this is behind my head. Variables. So we're going to use the elimination method to solve for one of the variables. So, all right, that's not a problem. 8x minus 3y equals 18. Negative 5x plus y equals negative 13. I think the easiest thing to multiply by here, it'd just be 3, because that would give me positive 3 and negative 3. So now I've got 8x minus 3y equals 18. Negative 15x plus 3y equals negative 39. These cancel, so I get negative 7x equals negative 21, or x equals 3. Step 4. Sub in known variable to find second unknown variable. Sorry about my handwriting. So my first equation, what do we got here? 8x plus, it's minus 3y. 8x minus 3y equals 18. All right, we just found out that x was 3. So 8x minus 3 times 3 equals 18. So this is 8x minus 9 equals come on, kids. Did you catch that silly mistake? X is 3, not y is 3. So this is 8 times 3 minus 3 times y is equal to 18. I knew that wasn't going to work out right. All right, so this is 24 minus 3y equals 18. Subtract 24, I get negative 3y equals negative 6. So y is equal to negative 2. Positive 2, positive 2, positive 2. Lots of places to make dumb mistakes, kids, because negative 6 divided by negative 3 is positive 2. So now your final step, and I don't really have room to write it, is to figure out what that missing variable is by plugging both of those back into that original equation. So we just found out that x is equal to 3. Y is equal to 2. Now we want to figure out what z is by taking these two and plugging me in here. So, oh my eye. Z is equal to, let me do this in black. Z is equal to 2 minus 3 times 3 plus 2 times 2. So z is equal to 2 minus 9 plus 4. So z is equal to negative 3. Now there's a really fast way, especially with the TI Inspire, to check your answer. So I'm going to come over to this TI Inspire. Let me clear out all this stuff. So I said 3 is x. So I'm going to take 3, I'm going to store it into x. That's the stow button. It's the stow feature. I'm going to take 2 and I'm going to stow it into y. And I'm going to take negative 3 and I'm going to stow it into z. Now I'm going to try to get this so I can see this. Can't see that. Can't see that part of the equation. Okay, so let's see if I can shrink this up just a little. Okay, so what I want to do is I want to type in that first equation, 3x. So 3x minus 2y plus z. Now if I'm right, it should equal 2. Got the right answer so far. Let's check. 5x minus y minus z. If I'm right, it should be 16. 16! And then x minus 3y plus 2z. And negative 9. And it works. There's my answer. There's a simple way to check that answer. I don't know why that didn't. And see if you got the right answer. But lots of places to make mistakes. We got 2 more examples to go through with these. I'll be right back. So if you remember correctly, our first step is to take one of the equations and solve for one of the variables. And, well, quite frankly, this is actually the easiest one to work with right here. Oops, I should be probably doing this in a color. Let me pick on this. I'm going to work with this equation right here because it's just the smallest. It should be a little bit easier to work with. So we're going to work with that equation. So I'm going to say C is equal to 2 minus B. Well, that was simple. And what I'm going to do with that is I'm going to substitute it into this equation and into this equation. So it's going to be A minus 4B plus 3C, 2 minus B, equals 9. That's the first equation. And let's see the other one in orange. 3A minus 2B plus 6 times, substitute in this equation, 2 minus b equals 8. Now, if I don't make any dumb mistakes, we should be able to get through this a little bit quicker. Let me finish this one since I've got the orange pen. 3a minus 2b, or not to be, oh my gosh, plus 12 minus 6b equals 8. So we're going to clean things up. I got 3a minus 8b, and I'm going to subtract this 12 over, equals negative 4. So there's one of my equations. Hopefully I didn't make a mistake. A minus 4b plus 6 minus 3b equals 9. Only one A. A minus 7b, and I'm going to subtract the 6, and subtract the 6, equals 3. There's my second equation. All right, so now I'm going to use the elimination method. I'm going to line them up on top of each other. Let's do this in purple. So A minus 7b equals 3. 3a minus 8b equals negative 4. Hopefully I haven't missed any signs. Oh my gosh, if I do, I'm going to have to go back and change them. Let's multiply this first equation by negative 3, because that would give me a pair of opposites, or additive inverses. Negative 3a plus 21b equals negative 9, and 3a minus 8b equals negative 4. Gone. 21 minus 8, that's 13b equals negative 13. So that gives me b equals negative 1. Looks like I'm almost done, right? B equals negative 1. All right, let's see. Do I have anything? I'm going to plug that one into, so I can plug that one into either one of these equations. Let's just plug it in right into here. So 3a minus 8 times negative 1 equals negative 4. So I get 3a plus 8 equals negative 4. Subtract 8. Subtract 8. I get 3a equals negative 12, or a equals negative 4. And then let's figure out what c. Oh, c is just equal to 2 minus b. So we had that earlier. Remember we had c is equal to 2 minus b. So in this case, c is equal to 2 minus, substitute in using parentheses, negative 1. So that's really a plus there. So c is equal to 3. So my three answers are A, B, and C. C was 3, B was negative 1, and I think A was equal to negative 4. And if you use the checking method, you'd see that they work. They do, in fact, work. All right, one more. I will pause this for a second. Okay, back to a harder one. It's harder because there's no simple equation like we had in that last one. So it's not as easy. So let's take this first equation. Let's pick a different color. Blue. I like blue. Let's take this first equation and let's solve it. I don't know. Let's solve it for m. So m is equal to 4 minus n plus p. See, because we're going to bring this n over, it makes it negative, and we're going to bring this p over, it makes it positive. Okay, so now I'm going to substitute that into the other two equations. So it's negative 5m, there's m, just goes right in there, 4 minus n plus p, plus n, plus, excuse me, I went to the second equation. See, that's a common. You got to be careful. You got to keep your equations right. Minus 2n minus 3p equals 11. And while I've got this pen out, I'll just clean this one up. Negative 20 plus 5n minus 5p minus 2n minus 3p equals 11. Let's see. I'm going to bring this 20 over here. I'm going to add that 20. So I'm going to have this equal to 31. That's weird. That's a prime number. 5n minus 3n, or 2n is 3n. And then negative 5p and negative 3p is minus 8p. So I've got one of my equations. Now I'm going to plug it into this equation. So 2m, so 2 times 4 minus n plus p, because that's m, right? Right in there. Plus n plus 2p equals negative 5. So 8 all right, somehow I can't. Oh, I know why. It's not letting me move over. I don't know why. Who cares? Let's just go through it. All right, so it's 8 minus 2n plus 2p plus n plus 2p equals negative 5. Okay, so I'm going to bring this 8 over. So that's negative 13 on this side. That's weird again. I've got negative n plus 4p. There's my second equation. I just combined the 2n and n's and the p's. Okay, so now I'm going to put these on top of each other and use elimination method. So let's use green. So 3n minus 8p equals 31. Negative n plus 4p equals negative 13. This equation is getting multiplied by 3. So 3n minus 8p equals 31. Don't change that one. Negative 3n. Remember, we're going to distribute this here, here, and here. Plus 12p equals negative 39. These cancel. I get 4p equals negative 8, or p equals negative 2. Woo! Now I'm going to plug this back into this equation just to find what n is. So 3n minus 8 times negative 2 equals 31. So 3n plus 16 equals 31. Subtract 16, subtract 16. I get 3n equals 15, or n equals 5. Now I'm going to take both of these, and I'm going to plug n in here, and my p-value, which is right here, into this one. So m, 4 minus n plus p. So m is equal to 4 minus n plus p. So plug it in, plug it in. M is equal to 4 minus, make sure you use parentheses, 5 plus negative 2. So m is equal to 4 minus 5 minus 2. So m is equal to negative 3. Boom, shakalaka, done. So I come back up here and I say, okay, m is negative 3, n is 5, p is negative 2. Now these are very frustrating only because you have to not make a simple mistake. If you notice, there's a little cutoff on that first problem because I made a mistake. I had to go back and fix it. Actually, I made 2 mistakes on that first problem, so I had to go back and figure out what those were. I fixed them. We're done. Common mistakes, lots of mistakes made. You got to be careful. All right, hit the subscribe button, hit the like button. Tell me what you think. Get the thumbs up. Then share the video on whatever you want to share it on. Tell your friends about us. nkinfinity.com, where we have an infinite amount of energy and more problems for you to solve. Bye, kids. Bye.